so these are called rational exponents. Okay, rational exponents. The reason they are called rational exponents is because rational is a fancy math term for fraction. Rational means fraction in math. It means when two things are divided by each other, it comes from the word ratio. It even has the word ratio in it. It's a ratio between two things. It's when two things are divided. It is a fraction. All roots, square roots, third roots, all of them are just exponents that are fractions. A square root can be written as something to the power of 1/2. A third root is the same as a number raised to the 1/3. Okay, so all roots are just exponents that are fractions. So what we're going to make sure we know how to do is we need to make sure we know how to go from fraction exponents to radicals. This is confusing right now. It will make sense in a minute. If you have a number, a is our base, and a is raised to the power of m over n. So it's raised to a power, and that exponent is a fraction. It's super yucky when it's like this. But luckily, I'm going to give you a way to turn it into a radical so we can do what we did right on the other page. So if you see something like this, 16 to the power of 3/2, yuck, that's gross. That's a rational exponent because it's a fraction. A, remember, is our radicand. It gets put on the inside. A gets put on the inside. The denominator, the bottom of your fraction, is going to go on the shelf. And then we're going to raise this to the power of m. So this is how we go from here to here. And then we would do everything exactly the same. Put in our calculator, find our real roots, or imaginary roots. If our exponent is negative, remember we hate negative exponents, and what do we do with negative exponents? Flip them. The saying goes, if an exponent is positive, they go to heaven, and if an exponent is negative, you can finish. That's how I was taught it. They go to heck. So, just like before, this is going to become first. It's going to be exactly the same, except it's going to be 1 over n square root of a to the m. The only difference, it's going to go into the bottom of the fraction. We take that whole thing and we throw it in the bottom. Okay, these are our little formulas we can follow. Otherwise, everything is the same. We're adding one little step. So if we look at number 1, the first thing I am going to do is I am going to turn this into a root. I need to turn it into a radical. Okay, so I'm going to draw my radical. I'm going to put everything where it belongs. My big 16 goes where? On the inside. That's my radicand, my a value. The number that goes on my little shelf is 2. So this is a square root. And we're going to then raise it to the power of 3. Did you know that a long time ago, a mathematician, right, he was working with exponents, right? It was a new hot big thing. You know, he was taking 4 to the power of 2, 12 to the power of 4, and then all of a sudden he was like, I wonder what happens when I take a number to the power of a fraction. So he's like, I'm going to raise 4 to the power of 1/2. And he was like, huh, it's just 2. And some dude way back then was like, instead of having fractions, I'm going to invent a new thing. And I'm going to call it the radical. We don't even need radicals. We don't need square roots or third roots. If that man never lived, then we would always just have exponents that are fractions. Square roots, third roots, they only exist so that we don't have to worry about writing fractions in our math. That's why they exist. Okay? I mean, me personally, which two of these are better? They're both pretty gross to me, but I think square roots are better than writing 4 to the power of 1/2, right? And just square root of 4 looks way nicer. That's why they exist. It makes math look nicer. Okay, so now we just plug this whole thing into our calculator. Just like we did before. Go to math. Plugging in our second root, which is just the same as the square root. Yeah, the square root's just special. It doesn't even, you don't even need to put the 2. You can just leave it. Square root of 16 to the power of 3. Enter. 64. But is it just 64? 64 and negative 64. Right?
Where do we put the negatives out? Below it or first?
So our calculator told us that the answer is 64, but we have to remember, because 2 is an even number, I have to include not just positive 64, but also negative 64. Both of those are going there. Alrighty. Number 2. Uh-oh, we have a negative, don't we? So we are going to follow this second little formula to help us. We know that we're going to do everything the same, except it's going to be in the bottom of a fraction. So I'm going to have 1 over my radical. And again, this is because of those laws of exponents. We do not like negative exponents, so we throw them down below. $32, my big boy number. Inside, Ratican. Is 3 or 5 my index? 5. The bottom number goes on the shelf. Yeah, everything's going to stay positive because we moved it to the bottom and that made everything. So yeah, once we write this on the bottom, this is actually now just a positive 3/4. We put it on the bottom so we won't have to worry about negative numbers. And then our 3 is our exponent. So this is a 5th root of 32 to the power of 3. Because it is a 5th root, how many solutions are we predicting? 1. 5th root. I wish that little ants didn't pop up. I don't like that. Oh, you are 100% correct. Yes. If you, so I would type in the bottom on its own because you're going to just get, you know, a normal number. But instead of our answer being 8, it'll be 1 over 8. You know what I mean? Does that make sense? Because this is in the bottom. The reason why I don't want to type in the 1, because if I do 1 over, can I just grab this? And I click enter, I get a decimal, and then I would have to use my math enter to turn it into a fraction. So if you did type it all in, you get a decimal, and then you just have to make sure you turn it into a fraction with your calculator. Whereas if you just type in the bottom and just remember that it's 1 over that number, but both ways would work. So odd, so it's just x equals 1/8. Now I put number 3 in here to throw you a curveball. On number 3, what do you think a lot of students try to do? Did you say flip? A lot of students try to flip number 3, but why would you not flip that? The a is negative, which is totally fine. You're allowed to have a negative a, but our exponent's positive. No need to flip. You only flip when your exponent is negative. Exponent is positive, so this is fine to exist in, it's going to heaven. Staying up top. So on the inside, we have negative 27. Our index, our baby 3, is on the shelf. And this is going to be raised to the second power. And here's where we go back to that awesome question. Will this be imaginary? It won't. Why is this one not going to be imaginary? Because it's odd. If this was even, it would be. Have imaginary, but it's odd. Okay, and we're allowed to take the odd root of a negative number. So we go to our little calculator. Hopefully we're getting good at plugging this in. Good button to know how to do. Third root. SAT loves radicals, by the way. Lots of problems like this hopefully show up on your SAT next week because they're quick, aren't they? They're not too hard. There we go. Plugged in, click enter. That is my only solution. Agree? It's the only one. X equals 9. Alright, go ahead and set up number 4. It's your time to shine. I'm sorry to bombard you with notes on Friday. When does it become an imaginary number? If your index, the number on the shelf, is even, and the number on the inside is odd. You will know it's imaginary because when you type it into your calculator, it will say, instead of giving you an answer, it'll say no real solution. It will tell you. So. Finish with number 4. Go ahead and keep going. I will write them up as we go. Done with 4, go ahead and check it. Remember that was a negative exponent, so you got to send her down to the bottom. Your number on your shelf was even, so you should have had two solutions, plus and minus. I have no idea what this one is. Toss it in. Number 5 was an even index, so we had both 32 and negative 32. And for the last one, because it was odd index, odd baby number, only one solution, which was negative 25.